Hey robot makers, hope you have a good day so far. So do you want to learn more about the Microbit, why it's probably smarter than you think? Then this is the show for you. Let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to our couple of slides, and ooh, that's not the right slide. There we go. So yes, this is all about the BBC Microbit. Is it still called the BBC Microbit, or is it just Microbit now? Anyhow, so yes, we're going to learn about what it is, just a quick recap of that, how it compares to some of the other boards that are out there, what it can do specifically that's unique to the Microbit, have a quick comparison between the 1 and 2, and a couple of the add-ons which I've got on my desk here, and then we'll get into a couple of demos, some really fun demos, one of them featuring machine learning, which is pretty cool, but you didn't know it could do that. So yes, these are made in the UK, which is another board, as well as the Raspberry Pi Pico. We also make these really cool microcontrollers. So this is the original microcontroller, I think the version 1, so that's got 256k of RAM, of flash even, 16k of RAM, 25 LED matrix display. I should grab one here, you can see what these things look like. It has 2 buttons on the front, so it's got an A button and a B button. You can program them as you like, but there's also a touch sensor there, so the logo is actually a touch sensitive button as well. So there's actually 3 buttons, and there's the LED matrix display, just a single colour red. It's got wireless capabilities, not Wi-Fi, but it has got radio and Bluetooth. We'll have a look at the radio capability in a second on our demo. And it's got an absolute ton of sensors on board. So it has a thermometer. It can actually use the LED matrix as a light sensor. It has a microphone, speaker, and it's also got these breakout pins on the bottom. And these are designed to be used with crocodile clips. So you can get your crocodile clips and you can just connect them through like so. That's the preferred way rather than like that apparently. But yeah, that means you can connect up some other devices such as this little fan here just by connecting up your crocodile clips and making a circuit. So these are designed primarily for kind of education, but they are so much fun, and there's so many cool things that they packed into the software for these. We'll definitely have a look at that in a second. These are now £15.50-ish. I think you can get them around that kind of price. If you're an education establishment, they do really discounted prices for schools and classes. So yeah, they're designed to have these crocodile clips, so you can connect up all kinds of other peripherals. My friend Simon from Monk makes, he makes these amazing add-on boards for the Microbit. We'll have a look at some of those a bit later on, where you can simply just connect them up with the crocodile clips. No soldering required, so it's nice and kind of classroom friendly. So yeah, we touched on the A and B button there, and the touch sensor as the logo, which is a nice touch. And they're powerful but not power hungry. This is one of the other cool things about these chips. So they're designed to be run on batteries. So you can get these little battery packs that have these little, is that a GST PH for power? A little connector. So these little connectors, I don't know if you can see that because it's so white, there we go. And these just simply connect up, where have I put that Microbit? These connect up nice and simply. Literally just lost that Microbit, where have I put it? There it is. So on the top there, there's this little connector. You can push that in there. And these usually come with like a power on and off button as well. And once you've applied power, whatever code is on there will then start running. So this is actually running some code we'll look at in a second. So you can actually see over there, every now and again, it'll say R. We'll look at what that means momentarily. Cool. So yes, very, very low power. So between 1.5 and 1.9 milliamps with no LEDs lit, between 2 and 30 when it's running code and doing lots of cool stuff. Compare that with the Raspberry Pi Pico, which is about 38 milliamps when idle, about 41 with the built-in LED switched on, running code. So significantly low power, and that's why it can run on a battery. In fact, I've had one of the project ones. It's actually outside the robot lab currently, sending data using the radio. We'll have a look at that demo in a moment. So yeah, you can power it by the USB connector if you wish. You can power it by the battery. It's got the reset button between the USB and the power, and it's got all those other sensors on there as well. So the version 2 has that extra sensor, which is the microphone and the accelerometer, the compass. It's got quite a lot of things built in there. We'll have a look at all those in a second. So pinout wise, so yes, what's really cool, you can buy these, here's a couple of boards that I've got that allow you to break out the pins. So instead of just using those kind of 5 connectors along the bottom, so you've got pin 0, pin 1, pin 2, 3 volts and ground, so you can break out that to control various different things. These breakout boards allow you to connect, just like on a Raspberry Pi, you can connect all the different GPIOs, of which there is quite a few. So you can see that we've got the 3.3 volt pins on there. We've got 3 grounds. We've got an SPI bus and an I2C bus for those kind of peripherals. We've got the A and B button connectors as well that we can read from. We've got 6 analog inputs, 19 digital input and outputs, and I've also got the LEDs on there as well. So really, really cool that we can do all those different things, or we can just use the very basic connectors with our crocodile clips as well. So they were actually given away to every Year 7 student in the UK back in 2015, so there's a lot of these around. And the Microbit.org, which is the Microbit Foundation, they also have a great source of tutorials, guides and videos, and they also paired up with Microsoft to develop the IDE for this, which is actually a website called MakeCode. We'll have a look at that very, very shortly. So the thing that makes this different and unique to the other microcontrollers that are out there, such as the Arduino family, the Raspberry Pi family, is that this has all these sensors built on board. So we have Bluetooth connectivity, we've got that speaker for outputting sound and speech. It can do speech out of the box as a microphone, so we can measure sound levels, we can record clips of sound into it. It's got a temperature sensor built on board, an accelerometer, so we can actually detect how it's moving around. It's got a magnetic compass in there as well, so we can even point and use this in our robots to figure out which way north is. And it's got 25 LEDs that we can use to show icons or scroll text. There's all kinds of things that we can do with that, and we can use those LEDs as a light sensor, which just blows my mind. That's so innovative that they've done that. So that's what really makes this unique. So let's have a look at some of those other particular features. So like I said, we can display very crude kind of images, icons using the LED matrix. So it's more surprisingly useful than you would think that. We can scroll text, so little messages can scroll left to right on there. We can detect light levels, not just that there is light, but different gradations of light. We can detect temperature, a bit like the Raspberry Pi Pico and the Arduino. We can use the onboard temperature sensor that's in the core. Now we have a built-in IMU, an inertial measurement unit, in the Microbit, so we can use this if we have like a wrist-mounted version like I've got here. This has a little battery pack which allows you to sort of wear this as like a wrist-mounted device. We'll have a play with that in a second. That means that we can measure all kinds of things. We can make like a pedometer where you can measure steps. You could use this to control something like a robot by moving your hand around if you're wearing that as a watch. So many different possibilities with that accelerometer. It's got the compass in there as well, so we can find out which way north is. It's got Bluetooth connectivity, so we can connect to other devices, or we can just connect to the browser if we're doing code and uploading it without any wires. We've got the radio, so this uses RF radio to connect to other microbits and send messages or data between them. That's what we're going to base one of our demos on in a moment. It's got the microphone, so we can use that to make, detect claps and things like that sound-wise, or maybe record a sound, some sound clips. We've got the speaker, surprisingly loud little speaker, so we can play music, we can play sound clips, sound effects, and also do speech, which is amazing. We'll have a look at that. So like I said, music and speech as well. So all those things right out of the box without any other hardware or devices connected on there. So they did launch a newer version in 2020. So the original one was in 2015, the version 1. So we're probably due for a new version, I would say, of this if they're going to do that. But I think they've really doubled down on keeping the hardware pretty cost effective and introducing new features in software. So version 2 launched in October 2020, and that had some extra features like Bluetooth 5.1, so the really low energy version of Bluetooth, built-in speaker, the capacitive touch sensor, the low power saving mode, and the faster processor. It's got a lot more RAM as well as that faster processor and storage. You can also get lots of add-on boards. So I've shown a couple. I'll just go back to the overhead screen here and just show you a couple of these. So that's the Pimoroni pin between. So that's a way of connecting up, and you simply just connect these in with the LEDs pointing forwards, like so, and then you can then access any of those GPIOs on there. You can also still access the original ones down there as well on that pin between version. Kitronix do quite a few cool ones as well. I'm not sure if I've got theirs to hand actually. Key Studio also do a breakout, and they've got access to things like these. I guess these are controlling motors on there, as well as a whole bunch of servo headers and GPIO pins as well. So that's that one. We've then got some of these. These are designed to be used as like a little kit, so you can let's construct something. I don't know, let's say the speaker for example. So we simply connect the ground to our ground on here, and then you get, I don't know, 3.3 volts. Connect that up to the 3.3 volts, and then you'd have some kind of signal pin as well. So you just grab one for that as well. So say we have the actual signal for the audio coming in on there as well. So that's how you kind of connect that up, and then we would just output this as regular sound, and it would come out the speaker nice and loud. So I'm going to turn that off for a second. So a whole bunch of extra add-ons. Like I said, Monk Makes particularly specialises in these. There's the 7-segment displays for the Microbit. Again, you connect it up in the similar kind of way. And there's things like nice slider switch, so you can detect different levels of the slide on there. And then there's that really nice sensor board. So you've got there all the different sensors. We've got sound, we've got temperature, light levels, all kind of separately broke out on there. An LED, RGB LED there, and I think there's a smaller version that's just like a bulb, 1 volt bulb, nice and simple. So you also have these nice little fans, so you can use these either as just a regular motor, or you could actually blow on the fan and take a voltage reading and see what the strength of the wind that's coming from the person blowing on it. I did that as a bit of a project when I was at Makers Fair in Rome last year before. So there's so many different breakout boards available. It's almost impossible to cover all of them. But one of the really cool ones I like is the Wearbit. So the Wearbit is that by Elect Freaks. Definitely a friend of the channel there. So this one you simply just screw into this little strap, the Microbit, and then you put a little coin cell in there, and there's a little switch on the top which is just there. So as I switch that on, you can see there's a bit of LED activity going on there. There's actually a little smiley face on there. If I put it on there, you'll be able to see it a little bit better. So that's the Wearbit. We'll be using that one in our demo any second. So let's go back to that one there. Okay. So to upload the code, we can do this in 3 different ways. We can use something like Thonny with a USB cable. We can connect up. We can use Microsoft Make code. We can drag and drop the .hex files, which is how it compiles the code, directly onto the Microbit. It shows up as a drive, a bit like CircuitPython. Or we can connect over Bluetooth to our browser using Microsoft Make code as well. So lots of different options there for uploading code. So it's particularly easy to use in a classroom. You don't have to have loads of USB cables all over the place. So if you like these kind of videos, you want me to make more of these, definitely drop me a like on this video. Let me know if you have a Microbit. I'd be very interested to know how many people have them. Let me know like whereabouts in the world you're based and what version of Microbit you have. And if you haven't subscribed to the channel, please subscribe. It means so much to me when people subscribe. Okay, and I do go live every single Sunday at 7 o'clock British Summer Time. That'll be GMT if you're watching this on replay in the winter times. But yes, currently in British summertime, daylight savings time for the US. So did you know that the Microbit can do machine learning? I didn't really realise this until quite recently. This is specific to the version 2 because it has that extra RAM and slightly faster processor. We'll actually have a play with this right now and do some machine learning. We'll build a little model, we'll add some data, we'll train the model, and then we will test the model out. So we'll do some very, very simple coding on this. So we're going to go to this ml.microbit.org, and I've actually got this one loaded up already. So I'm just going to go to the next slide, which is our demo. Okay, so let me just break out the screen over here for a second. And what I'm going to do, I'm going to first of all show you, let me just make my screen a bit bigger before I flick over to the screen. There we go. Okay, so this is MakeCode. This is Microbit MakeCode from Microsoft. What I really like about this is it's a really polished interface. It's very, very simple, and we can do all kinds of simple things. So I've got over here, if I can just grab this without knocking everything over. I've got my Microbit plugged in, and it's running the exact same code that you can see in the simulator there. So it's simply just saying, hey robot makers, and there's a little Pac-Man ghost thing as well. I'm just going to put this back on the table over here. And I'm just going to quickly show you around this interface, and then we'll get into the machine learning demo. So there's so many things you can do in this, and they've just made it really, really nice. If I was going to design one myself, I wouldn't have thought something quite as neat as this. So first of all, let's just get rid of that code that's currently running on there. So we simply just grab that, throw it over here, and it becomes like a trash can. On start and forever, these are, you can have some code that just runs once at the beginning, or you can have some code that runs all the time in the background. And if we go to this basic thing here, we can grab this like show LEDs, and we can make like a little smiley face. Let's do a really bad smiley face there. So if I do that, when we wait for a second, and you can see that the simulator is now showing that. If I click on download, it'll actually download that code directly onto our Microbit that's just there. So you can see it's actually loaded directly on there. So that's really, really neat. So we've got a whole bunch of separate things on there. We can show some icons instead. So if we want to do that, let's just drag that one out, put that show icon on in there. And there's some kind of pre-designed icons. So we've got like a skull, for example. You can see on the simulator that's what that looks like. And we can also do things like show some text. So this is surprisingly useful, particularly as like a debug tool if you're wanting to write some code and see where things are at visually on the Microbit. So we could say like, hey robot makers, like that. And then it'll update, and you can see there, that's the kind of speed it will scroll across there. With it being only 5 pixels tall and 5 pixels wide, they've had to be quite careful in the choice of characters there, but they do have uppercase and lowercase, which is pretty neat. We can even do things like clear the screen on there as well. We can pause for a second or two, and that's measured in milliseconds. And we can even do things like show north. We could that's grabbing the direction from the compass, which is pretty neat. So if we get rid of that, if I just move that up there and get rid of that there, we can then see in the simulator it's now detected that north is straight up. But if I download that code onto the actual Microbit, let's just click on that, and then let's go to let's see, sorry, that one there. So if I move this around, is it going to show where north is? Oh no, I think it might just be pointing straight up actually. So do we actually have the compass in there that we can grab? We can actually do that. I'm just going to show you it actually running, and then I will. There we go. So that says tilt. So that should be the compass heading in degrees is what it's showing me there. Let's go back to, so I simply just grabbed that compass heading from one of the inputs that's on there. So there's all kinds of extra things that we can grab. Things like temperature, for example, we can grab that. So let's not show an arrow, let's just show that as some text, for example. Show string, grab that, put that in there, and then let's show the temperature. So throw them back in the trash there as well. Okay, and then we can again download that code, and that will download it directly to the Microbit. So just waiting for it to show that. So currently we're not actually getting any temperature showing on the Microbit itself. There we go. So it says 24 if I go to the overhead. And I did that on start. Let me drag that to forever. And therefore it'll keep showing that over and over rather than just once. That's why I couldn't see when I looked over. So 24. Probably running a little bit hot because it's inside the processor's core, and if the processor's quite busy then it will get quite hot. It's not quite that warm in here, it's about 20 degrees according to the air conditioning that's on at the moment. Cool. Let's jump back over here. So there are so many things that you can do in here. I also want to show you the music, so we can play a melody, for example. Let's grab that, let's put that in play on start. Let's get rid of that show on there, and then if I download that code, you can see there you can connect up a speaker. Now we can actually connect up let's do that with the McAleer speaker. So it says connect up like so. Let's see if I can hear this. Just doing this, and you can't see what I'm doing here. Just flick over to here for a second. So I'm just connecting up. Oops, not sure what's going on there with the glitching out of that. Right, so now that that's connected up, what I then need to do, it might be easier if I actually go to, nope, not that one, that one. Okay, so if I just make my screen a little bit smaller, we can see at the same time. So let's try that again. Let's download the code. I just hit a couple of clicks. Maybe I've not got that quite right. Now, what I wanted to show you on here is the way that you can actually edit things is so nice. So if we go back to that music and we find the ringtone hertz, and if I click on that, you get this nice little keyboard. So I don't know if you can hear that. How nice is that though as an interface? I really like what they've done on this. So there we go, we can simply just, yeah, I can hear that coming through. And then if you want that to stop, I think there's a stop all sounds thing. There we go. Let's just drag that in there and stop all sounds. Let's duplicate that, because it's just buzzing away next to me and it sounds terrible. Thank goodness it stopped. Cool, so there's a couple of examples of things you can do. The LED editor is also like the nice one that I showed you just a couple of seconds ago. We can even show number values on the LED screen. We've got all those music options. We can do sound effects. The sound effects is pretty cool. Let's just put that in over here. Get rid of the rest. Let's say stop sound after we've done that. And if we click on that, we get this nice little interface. Let's go full screen on this one for a second so you can actually see how cool this actually is. Let's make that screen a little bit bigger. So you've got the editor, you can play the sound, but then you can also play around with it. You can move, you can change the shape of the wave, which is pretty neat. And yes, there's generate similar sounds. And there's a whole bunch of other sounds like laser, oops, radio, jump, water droplet, kick drum, toms and snares, hi-hats, cowbells and triangles. So they're pretty neat. I don't know if you can hear those. Cool, cool. So that's another really nice feature. I just love the interface that they built for that. Okay, let's get over to the machine learning, which is the demo. So I'm over here on ml.microbit.org/thenextgen. And you can see here we've got this start session. So for this tutorial we will need 2 microbits. So I just happen to have 2 microbits here. I'm going to disconnect them so I can work with them. And I'll also share my screen when we're running code at the same time as interacting with them. So for this, I'm simply going to use that microbit that I've already got plugged in, and I'm also going to use this wearbit. I think it requires me to plug in the cable to this wearbit first, so I'm going to do that just now. I'm going to click next. So it says ready to wear, so we've got that ready to wear. We've connected up the USB cable, and it says just make sure you've got that selected when you click on the connect. So if I just say that's it, connect there, it's going to download the code. And I think this isn't running MicroPython. I think this is actually running like a C program, so it's allowing it to have more RAM available to load the model into, and it'll also run the model a little bit faster than if it was on there. Right, so now that I've got that loaded up, I can actually wear this. I'm going to wear this on my right wrist. It's a little bit tricky to fasten this with one hand. Let's just get that on there. Okay. Just need it to stay still when it's on there. What have I done here? That's really fiddly. Let's just do that one more time. If this was not a live stream, oh, I would edit this bit out. I didn't drop it. Cool, just need to make sure that that is all good. It seems to be like back to front. I'm not sure what's going on there. Right. Sorry, just have to bear with me while I do this. Just go full screen for a second while I try and do this again. It's as if the strap is on backwards for some reason. The little pin thing that goes through is kind of in the wrong place. There we go. Is that going to go through there? Right, I'll just have to carefully hold it like this. So I've got that on there. I'm going to switch it on. The little switch that's there, and then I can see that there's some LEDs. It's got a little smiley face on it. Right, so what it's asking now is, now that that's connected up, that's good. We now need to connect the second microbit. So I'm going to get my second microbit, connect that up. I think, there we go. Yeah, the little pin on the thing had gone through and kind of gone on the other side. So let me just put this back on properly. You'll see why I'm struggling to do this in a second, why this is important. Right, so let's select next on there. We're going to do the same thing again where we connect it up. And while that's downloading that code, so we need to make sure everything else is. There we go, that's better. Finally got the microbit on properly now. Right, so have I got that connected up? Yes, I have. Let's click on that, click connect. So why does it think another process? I think it might be because that other window there. Let's just close that one down. There we go, that'll be better. I had 2 windows open and therefore they were both competing for the same resource. There we go. So it's going to download again another special not MicroPython, a C program. This is why it takes a little bit longer. Once it's done that, we can then start using and training and capturing data. Right, okay, so you can see I've got this on my wrist here, and as I move my wrist you can see that the three different X, Y and Z values are changing proportionally as well. And it's getting data from here, sending it by Bluetooth or RF, I'm not sure which one it is actually, and then it's connecting up to the second microbit, which is just here. So what we need to do is we need to capture some data. So what I'm going to do, I'm going to wave. So I'm going to call this one wave. And I'm then going to capture some sample data. So what I'm going to do is wait, and then I'm going to wave. You can see there's the kind of up and down. If I do another one, so let's do a slow wave. And then let's do another one. Really fast wave. You can see there we've got different, it says microbit disconnected during recording. That's not great. We don't want it to do that. Okay, so let's try a second action. So this one is going to be a clap. So let's do that one. So maybe I think the battery is coming out ever so slightly. That's probably what's going wrong there. Let's try that one again. Oh no, it's disconnected. I'm probably just going to go for the wave one. Let's try that one again then. There we go. I just wanted to have more than one sample. I'll do a faster wave. There we go. Let's try the clap again. I'll do a double door clap. Let's do another one of those. Nope, disconnected. I think it's me shaking the battery loose. There we go. Let's get another one. I think we need 3 samples of data for each. Okay, and then we'll have a nothing action. Let's call this one nothing. You'll see why this is important in a second. Well, actually, let's not do that. Let's just go with, yeah. Let's just delete that action. Okay, we've got enough data there now. So let's go to the train model. So you've collected enough data to train the model. Let's train the model. So this is that data, those little snippets of data. It's going to send it off to its little server on the web. We've trained our model, that's how quick it is, and we can now test it. So it thinks I'm currently clapping. So if I wave, it definitely picks it up as a wave. Let's try some clapping instead. It's disconnected again, there we go. But if I do nothing, it's going to think I'm still clapping, and that's why when I was saying we probably need to have a third option, which is like nothing. So let's add that in, nothing. Let's just record me doing absolutely nothing. Another one, and another one. There we go. We can go back and train our model again. Let's retrain our model this time. So click the button. You don't get very much feedback on there that it's actually training the model. We can now test the model. So if I do nothing, got the estimated action is none, and we can change the recognition points on these as well. So if I put that down to there, it can see that I'm doing nothing, for example. And if I clap, it's picked that up as clap. If I wave, it's picked that up as a wave. So that's just using the sensor data from the IMU, from the inertial measurement unit, detecting the X, Y and Z positions of where my hand currently is, and then running that through a little sample of data that we've collected there. So that's really, really cool that you can do that. I didn't know you could do machine learning on a microbit. I thought that was pretty neat. So what we'll do now, we'll do a different demo now. Let's go back to our slides for a second. So let's do a garden data logger. So we're going to use radio in this to connect to another sensor. We're going to have 2 microbits running code. One is going to be the sensor that's out in the field, and then we're going to have another one which is kind of local in the robot lab. So I've actually got outside in the garden, I've got a Microbit that's in a Stevenson tube. It's in a kind of rainproof thing on battery. And so I'm just reading that comment from Ford. I don't really understand what that means. Yes, so the Stevenson tube protects it from any kind of weather, like rain, snow, stuff like that. And it's running a little battery pack, one of these very small battery packs like that. So it can actually run for several days. The batteries, I had 3 AAA batteries and a little battery pack, and that one lasted a good 3 days, continual use. So what I'll do now, I'm going to show you exactly how we build this from scratch. It's a lot simpler than you'd probably expect. Right, so let's go back to over here. Let's go to Microbit, make code Microbit. There we go. Let's do a new project. Let's call this one Live Garden Sensor. Okay. So I've got my notes written down here already. We're going to use the block. I'm also going to show you another cool feature, of the MakeCode interface once we've got this up and running. So the first thing I'm going to do, because we're using the radio, we need to set a radio group. So I'm going to do that at the very beginning. I'm just going to say let's use radio group 1. We can type in any number we want there. I think 1 to 99, I think. We're then going to have a loop. I'm going to have a while true loop. So let's grab this one. This is going to be enough for... we could actually have it just running... Oops, down here. Just messed that up. Let's just put that back in there. So while true, just like we have in regular MicroPython programs, then we're going to do something. So the first thing we're going to do is we're going to set some variables. So let's create the variables. Let's have a temperature variable. Let's create like a brightness. We can use brightness. Let's create a third one, which is going to be sound. That's like the sound levels. It's got these 3 variables, so we can now use this set to set the value. So we can say set the temperature value to, and then we can actually bring in that input, which is our temperature input. We can put that into there. So we're now going to load our temperature as temperature. So we just need to do that with the other variables. So let's have the sound as, let's go to our input, let's find our sound levels, place that, and then let's duplicate that one last time, throw that one in there, and then let's set our brightness to the light levels, the light level there. Okay, drop that in there. And then when we've done that, let's create a new variable. Let's just call this one a message. And then we're going to set that message to be, and then we want a string. So we could write all this code just dragging and dropping. The reason that these code blocks are very common in education is you can't create code that is kind of invalid. The syntax of the blocks and the way that you configure the blocks with values, it means that you're kind of forced into writing code that will work. But we can switch over here and see the MicroPython instead. So if we wanted to, for example, this message, we can say let's set this message to be the temperature. Let's have, oops. Let's try this. L is going to be light level, so I think we call that one brightness. There we go. And then S is going to be the sound. It's going to move me out of the way for a second while we do that. And that's going to be our sound. I'm not sure these squiggly brackets is the correct syntax for doing this. Let's see. Yeah, I think what I might do instead, because I don't think this version of MicroPython does F strings, if you know what they are, so I don't think we can embed the variables like that. But what we can do is just do this instead. Let's just do a comma after that one, and then finally have that like so. and then that should, I've got that correct. Yeah, maybe not. Let's have plus then instead. Or was it ampersand? I'm terrible at this live coding business. Let's try it plus instead on there. And yeah, I think the other thing is message needs to be a string at the top there as well. That's probably why it was complaining about that. There we go. So that's now a valid message. And if we want to write that, let's go back to our blocks and see what that looks like. So we get that big join command that's going to join all those bits of strings together. That's fine. So we also want to send this via the radio. So we want to send a string. Let's do that. And the string that we want to send is our variable message. So we can just grab message and drag that in there like so. We can also, if we want to make this a bit easier to understand, we can show a string on here, so we can have this one as being like an S for it's sending some data, and then we can wait so many seconds. So let's have I think this is it in basic, the wait command pause. There we go. We can also set a wait as well, I think, in the radio. Nope, it's not that one. That's fine. Let's check on there. That's all good. If we don't know where something is, we can also search for it. So if I say set, there we go, set. So I think it must be our variable that we were looking for. There we go, set. Set the wait in seconds. We need a new variable. Let's call this one wait in seconds. And we need to set that to be 2 seconds, so 2000 milliseconds. And we want to clear the screen after we've done that. So let's clear the screen. And then we want to pause for wait in seconds. So let's grab that variable and put that into that block there. So we can either look at it like that, or we can look at the MicroPython code and we can flick between the two, which is pretty neat as well. You can see there we've got a simulation of what's going on there. So what I'm going to do now is download this code onto the Microbit. Now, because it hasn't got MicroPython on it currently, because we wiped it with that machine learning code, it has to like download the entire MicroPython environment onto the Microbit. So we only have to do that the very first time. Any changes we make to the code and we click download will be much quicker now that MicroPython is installed. So for example, if I were to just change that value there to a 1 and download this, you can see it's much quicker. We can change that one back to 0. It gets overwritten anyway, so that's fine. Right, so now if I hold this up and I show you, every now and again it'll send some data. It'll send it to group. Let's go to that over there. If I show you this here, you can see it says S every now and again, and that means it's sending some data. Now if we go to this show data in device, whenever data is being sent and we're writing to the console, we will be able to see that data on there. So what we could do, if we go back to our code, we can go to the advanced, go to the advanced, and we can do a serial output, and we can write a line of text. So we could like write a serial write string. Let's do that. Let's move this to the bottom of our, so we've got that show string. We could also write that message. Let's go to our variables, grab message and put that in there. So that will actually write it out to the serial let's see if we can do that. Show device data. So it should actually log that out to the console. But I'm actually not seeing that on there, which is not quite right. Let's have a quick look at the Python and see what we've got going on there. Serial write message. So that should work.
Sorry, some accessories didn't respond.
Okay, let's go back to blocks. So that's part 1 of the code. We now need to write another block of code, and we need to connect up a battery to this so that this can continue sending data to us. So let's just grab this and plug in this so this is continually sending out data. Just switch this on. Right, so that's now sending data to group 1. I'm going to get my other Microbit and connect this up, and we'll now need to write some new code. So let's just put that on the desk there. Let's go to the home. Let's create a new project, and we'll call this one Garden Receiver or Server, if you like. Let's create this, and this one is much simpler. So the first thing we need to do with it working with radio is we need to grab the radio. I'm going to set that to group 1, and then we need to have another block which is on radio received, and then we can do that serial write line which we just did as well. So serial write line, let's grab that down there, and we want that to be that received string rather than received number. Let me just find that. So I wanted that one instead. Let's just put that down there, put that in the trash, and then we can just grab that and put that in there as well. So we're going to write out whatever we've received to the serial line, and we'll check what that is. We can also put something on the screen. Let's grab show string, and let's do like a R for receive, so we can see that we received some data. We can have a pause for, leave it at a tenth of a second, and then we'll also clear the screen once we've done that so that we can actually see that we've had something happen. So if I now download that code, we'll see on here when it's received data, if we put these side by side, we'll actually be able to see them kind of synchronize up. So as this is sending data, this is receiving it. So let's see now if we can do show device data. There we go, we've got data coming in. We have 23 degrees, we've got 166 as the light level, and we have 82 as the sound level. So that's the sound of my voice. So if I put this right next to one of the studio lights, for example, we should see that the brightness goes a little bit up. So there we go, we've got 255. If I put this under the desk where it's really dark, we can see that that value will drop down. There you go, it's gone down to 0. If I put this near my voice as I'm speaking, we should see the sound levels increase. Hopefully that's, yeah, there we go, 90. And the temperature, if I put my hands over the board and try and warm it up a little bit, we should see that that goes up as well. There you go, the temperature now jumped up to 26. Got this nice little graph here as well being displayed on the screen. I just move that down a little bit. You should be able to see that as well a little bit better. There we go. Cool. So how cool is that? We can send data using radio between two microbits. Now if I go back to that one so this is the one that's receiving. If I change this to 42 and I upload this, we should actually get some data from outside, because that's data that I've got one of the microbits running outside. It's a little bit cooler out there. You can see it's 13 degrees. It's a little bit darker outside. It's a bit overcast, and it's inside that Stevenson tube as well, so not all the light's getting in. And the sound level is 71. That's the kind of ambient sound of outside. 67. I don't know if that's like something decibels, micro decibels or something. I have no idea. I have no idea what these numbers actually mean, but you can see that it's pretty quiet outside, and the temperature's a lot cooler. So we can use these to connect over quite a big distance. I believe it's a couple of meters, 70 meters or something like that, the RF works over. And if we look at the microbit itself, you can see the little antenna is on there. This little squiggly line at the top corner there, that's the antenna for the radio. I love the fact that this is all built in, and you know, it's quite uncomplicated, but we've seen there we can write some code that actually interacts between two of them. So let's go for a final demo. How can we take that readings between these two RF devices and do something with it? So let me load up Visual Studio Code. So I'm going to jump over to me for a second while I just create a nice blank window and a blank file. I shall share this momentarily. Let's create a new file. Let's make this a Python file. And let's get my code up on my other screen. So what I've got over here, I'm just in Visual Studio Code. There we go. And let me just bring down the screen so you can actually see that I'm in Visual Studio Code, because that looks very dark. I'm not sure what's going on there. It's just me on a black background. It should be sharing my screen on there. Let's see what's going on. There we go. So if I jump to there. Not sure why Visual Studio's not liking that. Let's go back to that view there. You don't need to see my face. Okay. And we shall zoom in a little bit as well on the whole text, just so you can see this a little bit better. So it's that and equals. There we go. Okay. Right. Let me just load up my other screen. So I'm going to import Serial. So I need to make sure I've got Serial installed. I've also discovered a whole new way of creating virtual environments and things with UV. UV is a really cool new way of creating virtual environments and managing your kind of Python dependencies and everything. So if I do UV, VMV, VMVE, UV add init, that will also create a couple of other files in this area. Anyway, let's just do UV, source, and then VEMV bin and activate. That activates our virtual environment. If I now do UV pip install Serial, I think it might be called PySerial. There we go. We also want SQLite, which is built into Python, so we don't need to import that. We don't need to install that. So import SQLite 3, and we'll also import time. Right. So what we're going to do now is set up our serial port. So on this Mac, we'll find out what the serial port is that we are connected to with our Microbit. So if I do ls/dev/tty and just press return, let's do star, it'll be called something like USB modem. So there you go, USB modem 1102. So if I call that there, USB, so dot USB modem 1102. Okay. And I want the baud rate to be that. And then the connection to our SQLite, this is simply going to be called garden.db. We need to create a cursor for our database, so con.cursor, that's fine. And then we need to create the table if this doesn't exist already, so c.execute, and then in here we need to do create table if not exists, center data. Let me just get rid of some of that stuff. So we want to have timestamp, that's going to be a text. We want the temperature to be an integer, we want the light to be an integer, and we want the sound to be an integer as well. Let's just make those somewhat neat. Okay, and then close brackets, and then we can do con.commit, and that will create that table if it doesn't exist. And then we can have a while true, and we can say line equals serial.readline, decode UTF, I think it's UTF-8 by default, so that's fine. And then we can have strip, which will just strip out anything else that's non-character related. And then we can have line.starts with T, and sorry, it's adding lots of extra stuff in here that we don't need. Let me just get rid of all that auto stuff that's in there. Right, so if it starts with a T, then we can say try parts equal line.split, and we want to split by the semicolon, and we want to do the first one, which is the, so let's do line.split by comma, sorry, first of all, And then the first thing is the temperature, so that's going to be equal to, we want it to be an integer, and we want it to be, let's get rid of that, we want it to be parts 0, so that's the very first part of the array, whatever the first item is, dot split. Yeah, and we do want to split it by that, and this is because the way that the text is coming in is we have like t colon and then the actual value. So if we now do that for the lights and the sound, and then yes indeed we want a timestamp to be time string from time, and then we can parse it like however we wish. So that looks good. We then do c.execute, and we want to insert that that data that we've just done into the sensor data table. And Jeff Gale is saying, editor is here. I heard you like documentation on every line entered. Yep, I need to figure out how to turn off that autocomplete when I'm doing live demos, I think. It really doesn't help, does it? Right, so we've edited the, inserted the data into the database, we've committed it, and then we just want to have like a little print which just says like, yeah, data saved, like so, and then we can have an exception just like it says there. If there's some kind of problem. That's it, that's all we need to do. What that's going to do, if I run this code, let's see if this is going to work. Let's just say, yeah, import, that's fine. Yes, yes. Okay, whatever. Alright, so it's not found the... it might be a bit easier if I save this code into an actual folder, so let's just make a folder that's called live demo. And let's save this imported serial into that live demo space. So let's save as into live demo. And let's make sure that we're actually inside that live demo folder. And if we open this up, yep, we're inside live demo, which is good. Yeah, that's fine. And I have actually got... sorry, let me just rename it. It's called import serial, which is just like a horrible name for an actual file. I've actually got a marketplace extension that allows me to view SQLite files. Let me just try that one again. So it's just saying it can't find that serial, so let's just make sure we're in that virtual environment. I'm just going to do that again. So uv init, uv pip install PySerial, and we need to make sure we're inside, so we haven't got the virtual environment, so we need to do uv vmv. It's really quick to do this as well, much quicker than if you do this in Python. There we go, so we can just activate that now with source vemv bin activate. We can then do uv pip install and PySerial. Okay, and then we can try again and see if that code will run. Well, let's just run it in here instead, so let's call that like so. Right, so it can't find that USB modem. Let me just check that that's actually correct. I've probably done a typo on there, so let's do ls dev tty, is it tty dot USB modem like that. So let's just change that string. So tty dot USB modem. Right, let's try that. So have I not saved that file? There we go. Let's try that again. Oh, and then there's a syntax error on there. So what have I done wrong on my creation? Let me just check that. So line create table if not exists sensor data, open bracket, timestamp text, integer, light, sound. We don't need that last one there, that's probably what it'll be. Let's try that again. So that's on read line. Sorry, terrible. This is because I was like speed coding this and that. So it's SER. There we go. Let's try that. Okay, so let's see if we're actually receiving data and are we actually putting that data into our database. It looks like that is actually working now. So if I go over to here, and let's just bring up that so we can actually see what's happening. So it's saying list out range. That must just mean there's some funky values coming through there. Right, so now that we've got there, we can actually find that database folder. Let's just open that folder that we've just created, which is here, live demo. And that live demo, yeah, let's save those changes. Sorry, this is like all over the place. This demo, I'm trying to do things in a really bad order. Right, let's just try opening up that. Oh, don't save that. That's fine. Right, there we go. That's more like it. Yes, I do trust this. I am the author. So that garden.db file that I've got there, if I right click and open database, the extension that I've got installed means I can actually use this SQLite Explorer. I can see that there's a database called garden.db, and I can also see in there, if I just bring this up a little bit, because I've zoomed in so much, I think I'll have to zoom back a little bit. So I think that's that. There we go. We can see that there's a sensor data table, and if I click on this here, it'll actually open up all the readings that we've got there in this little window. So you can see there that we've got several readings coming in, and if I refresh this, as new readings are taken, they'll be added to the bottom of the to the table there. So we should have a couple more readings coming through momentarily. So how cool is that? We've actually made a kind of bridge between Microbit code using RF to connect to an external sensor, which is battery powered, and then we can read that into a Python program connected to a Mac or Raspberry Pi over the serial connection, which is that USB, and we can then take those readings as text strings and then put them into a database. So we can do some quite funky things there. Let's see if we can get that table to update there. Maybe I just need to close that and reload it like so. Let's open that back up. You can see that there's the readings that we've got so far. Cool. So I just need to make sure that that code is actually running at the moment. I think that's why it's not taking any additional readings. We probably just need to do that whole source vam bin activate Python, and then the actual code. There we go. Let's just run that, and we should be able to see some extra readings come through in here. One or two of them have been taken when it updates on here. There we go. So one's just come through. We should see that. There we go. Data saved. If I now refresh that and then upload that, you can see that extra lines come through there. Let's do that again. You can see our data table is growing. And we can, if we want to, we can graph that data with something like matplotlib. On the repository that I've created for this, I've actually got some code that does graph that. I think it's a little bit longer than I could easily type out in the time that we've got remaining. It's just a load of pyplots. I can probably just show you the code though on GitHub. Let me just define that. So if I go to github.com/Kevin McAleer and then /microbit database logger. Is this going to let me share my screen this time? There we go, Microbit database logger. And if I go to that log locally, that's the code that we've just typed out that logs it to the database file. And then this graphing code here, if I just grab that and I load that into Visual Studio on here, let's just do a new file, graph.py, paste that in. We will also need to just stop this for a second, do uv pip install matplotlib. That installs that, and then if we try and run this code, let's see if that's going to work. Maybe I just need to run it down there. So Python. Did that work? source UV pip install. Sorry about this. This is the worst demo. Install matplotlib. So that's installed. So Python, and then this is called graph.py. What it'll do is open up that garden database and just plot the data on a little chart. And if I click on that, there you go. That's the data that we've just logged from 8:04 to 8:09. You can see that the temperature dipped a little bit. We can see that the light intensity stayed the same and the sound levels have changed a little bit. So that's just an example of creating a plot using matplotlib. Cool. Okay, let's get back over to our slide deck. So 3 demos there of using microbits to grab data over RF, using the battery, using that very low power microbit microcontroller, and therefore it can run over several days on a couple of AA batteries, and it can send that to a computer that's connected to a microbit. The microbit can receive that data, and then we can then log that to a database locally and even graph that out. So pretty cool. So if you want to join our Discord community, we are over on Discord. Go to kevrobots.com/discord to grab yourself a sign-up link. It's completely free. You just need to wait a couple of seconds for the email to come through. Let's switch this off now. Save my little battery. And you can join our community there. If you want to follow me on social media, I'm on all the social medias. So go to Kevin McAleer at threads.net if you want to follow me on Threads. I'm on TikTok at Kevin McAleer 6. I'm on Instagram at Kevin McAleer. I'm on X at KevsMac. And I'm also on Mastodon at KevsMac at Mastodon Social. I'm also on Blue Sky at kevsmac.bsky.social as well. I share all kinds of behind the scenes things over on the social medias, and if you're on there, definitely give me a follow and say hi, and show me some of the projects you're working on as well. Will be pretty cool. Right, let me click on the next screen there. So if you want to get yourself on the end credits, you can do that by going to kevsrobots.com/coffee. All the instructions are on there. You can follow me and buy a coffee if you found any of this of any value to yourself. And let's give a shout out to the people who've done exactly that. So over here we have people who bought coffees. So somebody wanted to be nameless. There's lots of people who want to buy a coffee and be anonymous about that. That's cool to me. So 2 people have done that in the past month. We have an anonymous member as well. We've got Silicon Fiber, Marie TKD, we've got Andrew, Jeff, Diane Corty, Marlene and Tom on the Buy Me a Coffee membership. And then over here on the YouTube we've got Justice, we've got Pierre, we have Charlie, Octrad39, Bert, Marie, Michael, Steve, Ford, Bello, Paul, Johnny, Stephen, John Paul, Cassie, Tinkering Rocks, Johnny, and we have of course Tom. So thank you so much for sticking with me and supporting the show. It really means the world to me that you do that. Okay. And it's at this point in the video we've got the little spinny logo, and that means that YouTube will now be recommending over here another video for you to watch from the over 420 videos I think we've got on the channel now. So definitely watch one of those and let me know what you think. And it's at this point in the video I'll say thank you so much for watching, and I shall see you next time. Bye for now.